In this video, we're going to learn how to add and subtract fractions, both that contain common denominators and non-common denominators. So all of the fractions you see on this page, when they're being added together, have the same denominator. We're going to talk through why that's such an important piece of adding fractions. So we're going to actually solve these by drawing a picture visually so we can understand why our algorithm for adding fractions works. So here we're taking, in this first problem, 5/8 and adding it together with 3/8. So here we have a pi, and we already have 5/8. We have 1, 2, 3, 4, 5. Now, the really nice thing about these being common denominators is I know that eighths, the eighth size pieces, are going to be exactly the same because they're cut into eighths. So what happens here is I have 1, 2, 3. And really what we could do is say, well, take these three pieces and let's add them into this pie. What if we add 5/8 and 3/8 together? And what we find is that if we add 3/8 plus 5/8, we end up with 8/8, or a complete pi, which is just 1. So what's kind of cool is if we have a common denominator, if we have the same size pieces, we can just add the numerators and we leave the denominators alone. Now if we apply that here to this next problem, I'm going to draw out, we have 9/4 plus 5/4. So those are some improper fractions that make it a little more difficult. So here we have, we'll represent 9/4. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're adding it together with 5/4. So 1, 2, 3, 4, 5. So what we can do here is we can actually go through and we can say, well, how many fourths do we have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here we have 14 fourths, which makes sense because we're adding the numerators together, leaving the denominator alone because that's the size of our piece. And then this can actually be simplified further. 14 and 4 are both divisible by 2, so I'm going to simplify it like good mathematicians do, to be 7/2. So when we're adding fractions with like denominators, all we need to do is add their numerators, and then from there, leave the denominator alone. Now, just like subtracting integers, subtracting fractions, we can turn any subtraction problem into an addition problem. So that's what we're going to do here. We're going to use keep, change, change to help us out. So remember with keep, change, change, we keep the first fraction or keep the first number alone. We change the subtraction to addition, and then we make the second number the opposite sign. So this one is a positive 10/11, so now it's going to be a negative 10/11. So then from here, I can apply what I learned on the previous slide. I see that I have a common denominator. So what that means is that I can add my two numerators together and leave my denominator alone. So 7 plus negative 10 would leave me with negative 3. And then my final answer is negative 3/11. Here in the second problem, we're again going to use keep, change, change to help us. So we have negative 17 over 9. Then we're going to change our subtraction to an addition. And then we're going to change the sign of this one to be a plus 4/9. And then because I see a common denominator here, I can see that those denominators are the same value. We're dealing with all ninths. I can then add together negative 17 plus 4 to get negative 13/9. So now the next question we need to answer is, how do we add and subtract things that have mixed numbers? And my advice to you is to always start by converting it to an improper fraction and then apply what we know about adding and subtracting just fractions. So let's convert these all to improper fractions, and then from there actually perform fraction addition or subtraction. So here I know to convert this first value into an improper fraction, it'd be 2 times 8 which is 16, plus 7, which is 23. So I have 23 over 8, plus this one is 5 times 8, because we had 5 wholes. So we had 40 plus 3, which is 43 over 8. So we've converted these to improper fractions, and now we can already see that this is a much easier problem to solve. We can see that we have common denominators, so we know that as we're adding, our denominator is going to remain 8 because we're talking about how many eighths we have. And then 23 plus 43 gives me 66. Now, if you're a strong mathematician and you noticed, hey, both of these are divisible by 2, that's a great observation. We know we can simplify that. So this becomes 33 over 4. Now the next one, let's start by just converting these into improper fractions, and then we'll use our keep, change, change to help us make this easier, to convert it from subtraction into addition. So here we have 4 times 10, because we have 4 wholes, so that would be 40 plus 6, so this turns into 46 over 10. Minus, then I see, okay, I have 6 times 10, which is 60 plus 7, so we're subtracting 67 over 10. Now this is where keep, change, change is a great skill. We're going to use keep, change, change and rewrite this. So we have 46 over 10 plus a negative 67 over 10. I know that the difference between 46 and 67 is 21, and because the 67 is a bigger number, that's going to be a negative 21. And then I know because we have common denominators that my denominator is 10. So we have negative 21 tenths. Now if you wanted to take either of these and convert them back into a mixed number to make it your final answer, that would be okay. But in order to accurately add and subtract fractions, I strongly suggest that you convert them into improper fractions first. Now where adding and subtracting fractions starts to get difficult is when we do not have a common denominator. So notice here in this problem I'm talking about fourths, and here in this problem I'm talking about thirds. And if I draw this out in my fourths pie, that's the size of each piece. And in my thirds pie, the size of each piece is a little bit bigger. So they're not a comparable pie piece, and they can't be added together. But what we can do is we can strategically rewrite these fractions, essentially unsimplify them so that they both have a common denominator. So what I suggest you do is start thinking about numbers that are divisible by both 4 and 3. So think about 4 and 3. What numbers are divisible by both 4 and 3? And when I think about that, I think about 12. Because I know that 12 divided by 4 is 3, and 12 divided by 3 is 4. So what we're going to try to do here is we're actually going to rewrite these two fractions in terms of 12. So I'm going to unsimplify them, and I'm going to make them in terms of 12. Now, this looks a little weird the first time you do it, but once you catch on, it actually begins to make sense. So if I'm going to rewrite this first fraction in terms of 12, I know that I would need to multiply my denominator by 3. However, I can't just multiply my denominator by 3 because then the numerator would still be 1, and it would be 1/12, and 1/12 and 1/4 are not the exact same thing. So what I can actually do is if I multiply the bottom by 3 and I multiply the top by 3, I'm actually not changing the value of the fraction. So notice here that 3 over 3 is really a fancy way of writing 1. So what I'm doing is I'm multiplying 1/4 by 1, not changing its value, but in the end it turns into 3/12 because 3 times 1 is 3, and 3 times 4 is 12. And I know that if I were to simplify 3/12, I would go right back to this 1/4 here. But I unsimplified it for the case of being able to add and subtract fractions with uncommon denominators. Now if I look at my next one, 2/3, I know that in order to get the thirds to 12, I need to multiply it by 4, which then means I also need to multiply my numerator by 4. So again, I'm strategically multiplying through by 1. So 2 times 4 becomes 8, and 3 times 4 becomes 12. So what happens here is I unsimplify that fraction. I know that if I were to simplify 8/12, it would become 2/3. So now if I look at my fractions, what I notice is that I have a common denominator down here. They both contain 12 as a denominator. So I can add these two fractions together now using the strategy I talked about on the previous slides. When you have a common denominator, all you need to do is add your numerators together, and your fractions are now added. So when we are adding things with uncommon denominators, what we need to do is we have to rewrite the two fractions first in a way where they have common denominators, and then from there, we can actually move forward and add their numerators together. So here we're going to practice that same strategy with a couple more problems, and here we have a little bit more subtraction mixed in. So to start, what I'm going to do is I'm going to change this to a keep, change problem to make my life easier. So I have 4/7 plus a -3/8. Then from here, what I notice is that in this particular problem, 7 and 8 are not common denominators. So what I need to think through is what number is divisible by both 7 and 8. And if I think through that, I know that 7 times 8 is 56. So I know that 56 is one number that both 7 and 8 are divisible by. Then from here, what I can do is I can start to rewrite these two fractions in terms of 56. Now, in order to get the 7 to be 56, I would need to multiply my denominator by 8. So that means I would need to multiply my numerator by 8. So I would get 32 over 56, which, if I simplified it, would go right back to 4/7. So it's all a rewriting process. Now, if I look at the next fraction, in order to make the 8 in the denominator 56, I would need to multiply it by 7. So then I'll do the same to my numerator. So then I have plus a -21 over 56. So I've now rewritten both of these so they have a common denominator, and as a result, I can now add these two fractions together. The denominator will stay in terms of 56, and my numerator becomes 32 plus a -21, which those two numbers are 11 apart, and 32 is positive, so we would have 11 over 56 as our final answer. Now, if I look at the next problem, what I see are 4/13 and 1/2. So I have to think of something that is divisible by both 13 and 2 because I see uncommon denominators here, so I'm already thinking I'm going to have to rewrite them. Well, I know that 13 times 2 is 26, so let's aim for that to be our common denominator. Now, I know that in order to make 4/13 have a denominator of 26, that I'm going to need to multiply the 13 by 2. So I multiply the 13 by 2 as well as its numerator by 2, so I end up with 8 over 26. And I can still see, okay, if I were to simplify that, I'd go right back to 4/13. I then know that to change 1/2 to have a denominator of 26, I would need to multiply both the numerator and the denominator by 13. So this becomes plus 13 over 26. And then I'm noting here that I have a common denominator, which means that I can leave my denominator alone, add together my two numerators, which when added together become 21, and there's our final answer. Now this last one to start, let's first rewrite this so that we can use keep, change, and have only adding. So we have -8/9 plus a -2/3. Now what I notice here is that I have two denominators that are not common. They're 9 and 3. But what I notice is that 3 is actually a factor of 9. So while I could change both of these here to get a different common denominator, what I'm going to do is I'm just going to change this second one. Because I know that if I multiply the denominator by 3, that will be 9, and that can be combined with the other fraction. So here I leave the -8/9 completely alone, and then I multiply both the numerator and denominator of the second fraction by 3 to get -6 over 9. I then see that common denominator, so I can add them together, and I ultimately end up with -14 in my numerator, and then the 9ths in my denominator because I know I'm in terms of 1/9 size pieces. So next we're going to look at what do we do if we have mixed numbers that we're trying to add and subtract together. And luckily for us, it's just like what we did before with addition, just with that extra step of finding a common denominator. So our first step here, just like we did on the previous slides, is to rewrite these as improper fractions, because that's going to make our life so much easier. So just ignore that subtraction sign in the middle for now, and let's rewrite these as improper fractions. I know that I have 4 whole pies with 2 pieces in each here, so I have 8, then plus the 1 gives me 9/2 for that first improper fraction. And then I have the subtraction in between, and then this one over here, we have 3 whole pies of 3 pieces each, so I have 9 plus the 2, so I have 11/3. Now from here, my next step is I want to use keep, change, change to make my life a little easier. So I have 9/2 plus -11/3. And then from here, I note these do not have a common denominator. So I need to brainstorm ideas of what number is divisible by both 3 and 2. And the first number that comes to mind is 6. So I'm going to try and rewrite both of these fractions in terms of sixths. And I know that to do that with the first fraction, I would need to multiply the denominator by 3. So I'm going to multiply both the 9 and the 2 by 3 to get 27/6. The second one then, I know I would need to multiply the denominator by 2, so I multiply both the -11 and the 3 by 2. And then from here, what I note is that I do have a common denominator, so now I can add them together, and I have 22 plus -22, which is going to give us 5, and then we have the 6th in our denominator. And the last question we need to answer here is what do we do if we have fractions, mixed numbers, and just plain integers all mixed together? So the first thing that I suggest is if you have a mixed number, turn it into an improper fraction. So that's what we're going to do here. So here I have 3 times 3 for the 3 whole pies is 9 plus the 2, so that becomes 11/3. And then I'm going to do plus a -5. I'm going to use keep, change, change here. Now what's tricky here is we don't have any sort of fraction with the 5, but what we can do with any integer is we can turn it into a fraction by giving it a denominator of 1. -5/1 is really what that fraction is, we just typically don't write it. But now you can see that we have denominators of 3 and 1. So if we were to simply multiply that second fraction by 3 in both the denominator and the numerator, we would actually be able to rewrite these with common denominators. So we leave that first fraction alone of 11/3 plus -5 times 3 is -15 over 1 times 3, which is 3. So notice that by putting that -5/1, I was then able to take that fraction, compare it to the other fraction, and write them with common denominators. And now I can see that they have common denominators. 11 and 15, we can see that we have one positive, one negative. They're 4 apart, and 15 is the bigger number, so it would be -4/3 as our final answer.